let's keep going with that page. So what we have now is I want to use px to divide by a linear. Okay, to divide by a linear. Let's have a look. Okay, this is, I think most of you could do the long division, but I want to talk about when you divide by a linear, what's the remainder will be? What do you think the remainder will be? Well, if it's not divisible. Constant. Because you can see from the previous two examples, we are trying to divide by a quadratic. The remainder we have is a linear remainder. Well, it's possible to have a constant remainder as well. So it must be at least one power below what you're trying to divide. So you divide by a quadratic, your remainder is at least a linear or a constant. So that's why I write this thing, like the bottom here. The px divided by a dx, we equals to something on top, the qx. And my remainder still set rx, still involve x. Okay, still involve x, because it could be a linear. It could be like a constant, I don't know. So that's why I put rx there. But if we're trying to divide by a linear, let's have a look what could happen. We're trying to divide by a linear. I need to write a lot here, so I may use some of the space on the left-hand side as well. Let's have a look. If we're trying to divide, don't need that long, a px, trying to divide by a linear, which is ax plus b, well, linear notation x plus b, I will definitely have something which called, let's say it's qx. Okay, got some result qx. And then after we do all of these calculations, we will have our remainder. But your remainder will only be a constant. Okay, your remainder will only be a constant because it at least be one power down until you can't divide. If it's still a linear, I can still divide by the x plus b. So the remainder must be a constant. So that's why I just write the r there, not the rx. Okay, there's no x involved. Therefore, what we could do is, let's write the notation. So yesterday we talked about like px could be right in the way of qx times what you're trying to divide, that's the linear, and then we plus the r. Right? That one times that one plus the bottom one will give you the original function, which is px. Or you can say px divided by ax plus b, that equals to qx, and plus r over ax plus b. Or could be that one. But like I don't really need that one because I also talk about the remainder theorem and the factor theorem. So that's why I don't really need that notation. So just forget about it. But that's the right notation. Let's just observe for the px equals to qx divided by x plus b. And then plus r. That's the remainder. Let's have a think. Times. Yes, qx times ax plus b. I will write a times sign here. That one? Yep, times. Have a think. If I want to know what is r, and I don't want to do this long division. Well, think about I don't really do a number long division here. That's just a representation. I divide by ax, I will have a qx, and I have some remainder. That's just the structure. If I can make this term become 0, I will get my remainder, right? I will get my remainder. So how I can make this term become 0? I will need to make this term to become 0. How we can make that term become 0? That's why I sub minus b over a, right? Minus b over a. What you're trying to divide, make that equals to 0. So why I sub b minus b, or p minus b over a, that equals to q minus b over a. I can't evaluate, but because I don't know what is qx, but I don't care. The reason is this term will become 0. Right? The next term becomes 0. So I don't care what qx will give you. It will become 0 in the end. And then plus the r. So you simplify it, you will just get the remainder r here. You will just get the remainder r here. So this notation shows us the remainder theorem. That's why the remainder theorem will work. If you can make what you're trying to divide become 0, that x, when you sub that into the px, equation shows you when you sub minus b over a into the p, you will just get the remainder r there. Yes, that's the remainder theorem. That's why we have the remainder theorem there. When px is trying to divide by a linear, and then the remainder without doing the long division will be minus b over a. I don't really care about what is the qx. Well, this with limitations, I can only know the remainder. I'm not going to find what is our actual quotient is, but it's enough to find the remainder by substitute minus b over a. Also, the factor theorem will be if the remainder is 0. Well, if the remainder is 0, when you sub minus b over a and you get the remainder 0, then you have a factor there. You have a factor there. That's why when you sub a value into the px and you get 0, then that will become the remainder. Instead of say if, well, we can do this way. If ax plus b is a factor, then you sub minus b over a, you will get the 0 because you have a 0 remainder. We can say another way, which is more useful for later thing. So if we sub p, let's say pm equals to 0. Well, sub any value in, you will get 0 in this function. Then x minus m will be the factor. Okay, when you sub a value in, if this value can give you 0, which means that's the 0 remainder, and that value will make what you're trying to divide become 0. So how that could work is when you have x minus m, because x minus m equals to 0, x equals to m, and that should be the value you're trying to substitute into px. So x minus m will be the factor. Instead of say x plus b, that's too complex. I just want to easily find something x and then minus b. That's the remainder and factor theorem. So let's come back to this question here. So for this question, if I want to divide this by the linear 2x, so 3x cubed plus 2x squared minus x minus 2, and I'm trying to divide by 2x plus 1. Well, the number is quite bad for this question. 3x cubed divided by 2x squared, that's 3 over 2x squared. So 3x cubed plus 3 over 2x squared. What you have is 2 minus 3 over 2. That's give you a half x squared. And then you have the minus x down. A half x squared divided by 2x, you have a quarter x. Times with it, there's a half x squared plus a quarter x. And minus x minus a quarter x have minus over 4x. And then the minus 2 down. Minus 5 over 4x divided by 2x is minus 5 over 8. So minus 5 over 4x minus 5 over 8. So it's actually minus 2 minus negative 5 over 8. That's minus 16 over 8 plus 5 over 8. That gives you minus 11 over 8. Yes? 2x plus 1 times. Yep.
So we do a negative outside the brackets. Minus 5 over 4x.
Plus.
Plus.
No. It's minus 5 over 8 times 2x minus 5 over 8 times 1. So it's like this. Minus 5 over 8 times 2x plus 1. We expand, that will be 2 minus.
Yeah, and then,
Yeah, it's a subtract.
Yeah.
So that's here, minus 2, subtract negative of that. So that will become plus here. So we can say I'm not going to write the result. There's no space for me to write the result. You know, like that will be this times by this and plus that will give you px. And then ask you to evaluate p negative a half. What do you think the answer will be? P negative a half will be what? Negative 11 over 8. That's the remainder theorem, because negative a half will make what you're trying to divide become 0, and then by the remainder theorem, that will give you the remainder. Well, you should evaluate that, but like no space for me. I'm just going to give you the result directly. You should have negative 11 over 8, even though you substitute that. Okay, now I'm trying to divide by a linear. But this linear got some problem. I got a coefficient which is not 1 here. That's the problem. I got something coefficient is not 1. So I still can't use my method here, the synthetic method here. But I'm showing you this one by using the other method. So let's still quickly do the long division, and I'm going to show you another method, compare those two. So x cubed x squared minus 14x minus 24. Let's do this. X cubed plus x squared minus 14x minus 24. And then divide by x plus 2. So this number is good. So we have x squared, x cubed plus 2x squared. We have minus x squared minus 14x. Minus x here, minus 2x. So minus 12x minus 24 minus 12, and then equal, that becomes 0. Just work on yourself and by yourself, and then have a look at my answer here. This is a factor, like x plus 2 is a factor because I don't have any remainder here. It will be a factor. So the method I'm going to show you is the synthetic method. So this is only work for something trying to divide by a linear. And this linear better to just have coefficient of 1 for x. It still work for when coefficient is not 1. For example, that one is still working, but it's more complex. I'll show you, but like if you can't get it, just only do it by using a linear when you got coefficient of 1. So what I'm going to do is set up a table. Okay, 2-column table. And then we will write the coefficient of the px in order with each individual term. So x cubed, I got coefficient of 1. X squared, I got coefficient of 1. X, I got negative 14. And the constant is negative 24. If you're missing any term, for example, you don't have x term, you need to have a 0 there, okay, to keep the spot. So same as when we do long division, we're trying to keep the spot. Okay, next thing is I will write in the second row the number can make what you're trying to divide become 0. So in this case, we're going to put negative 2 because that's the number will make the what you're trying to divide become 0. So basically you solve x plus 2 equals to 0, what x equals to? X equals to negative 2, so you put negative 2 in this spot here. And now the other 4 box, we need to do calculations to fill those 4 boxes in. So the first box is always the number above it and directly copy the top number. So that's a 1. Directly copy the number above. Copy the number above. Okay, that's the first one. Okay, first one always do by copy the number above it. And then the second one, the third one, fourth one, we're all working by the same way. So 1 is the new number you work out. So what you will do for this next column, you will use the new number, go to times the -2 and add the next row, next column. So the 1 will go to time with the -2 and add the next column. So what you will have here is -2 but did I do it right? 1, 1, -14. Not 14, sorry. You need to add 1. You need to add 1. The next row, like the next row. So 1 times with that and add with that. So what we have here is a -1. Okay, -1 become the new number. So the next one you will use -1 times -2. You always go to times with the -2 and you add with -14. You see it's all doing by the same way. That one times with that and add the next column. So it's a 2 plus -14. You have a -12. Now -12 will time with -2 and you add the last one, which is -24. What you get here is 0. Okay, so what each box represent here? What each box represent? So before we have x cubed, x squared, x term, and the constant term. Then each column below that will be the x squared term, x term, constant term. Reduce everything by 1 and the constant will become the remainder. That's the remainder column. What you can see here, the 1, -1, -12. Is that looks familiar to you? The 1, -1, -12. If you go up, see the very top line I have 1, -1, and -12. Okay, 1, -1, -12. You will directly get the quotient, the QX. You directly get the QX. And also the remainder shows you that's a 0 remainder. I have the 0. So by this box, I will ignore all of the things in the middle. I will have the QX directly and I will have the remainder directly. So what we can write here is PX equals to x plus 2 times x squared minus x minus 12 and plus a remainder 0. You don't need to write it. It just show you like that's how we may get something, the remainder is not 0, so we need to add it there. So we have the remainder, which is the last box, and the previous box shows you the coefficient of your quotient, the QX. Okay, the coefficient of each individual term. You can see like we use how much space here and how much space here. This is a quicker method compared to long division. So that's why I said long division is something like I don't really like to use. There are so many places you can make mistakes. Yes? I can show you what's going on here. Here's my OneNote. Let's find some space. You can still do it. It's just you need extra step. So I still I will make 3 row here. Okay, so Let's see the coefficient. 3, 2, minus 1, and minus 2. Okay, 3, 2, minus 1, and minus 2. Okay, that's the coefficient. That's the x cubed, x squared, x, and constant. Well, we will have x squared term, x term, constant, and remainder. So, 3, 2, minus 1, and minus 2. And then what you're trying to divide is 2x plus 1. So I will make here become minus a half. You make that equals to 0. You solve for x. X equals to minus a half. So what we put is minus a half here. Using the same method to complete this column here, this row here. So the first one is always copy the number above it. So we'll copy 3 here. And the next one will be 3 times negative a half and plus 2. 3 times negative a half and plus 2. So it's negative 3 over 2 plus 2. What you have is half. Okay, what we have is half. And then the half will times with negative a half and plus negative 1. So that's negative a quarter minus 1. So negative 5 over 4. And the last one will be negative 5 over 4 times with negative a half plus minus 2. So 5 over 8 minus 2, which is 16 over 8. That's minus 11 over 8. What's minus 11 over 8? Do you remember that number? Remainder. Okay, so the thing is, doesn't matter whether you have a coefficient of 1 or not 1. The remainder always keep the same. So that's always minus 11 over 8. That number is not going to change. That number is not going to change. Your remainder is your remainder. This method works for the remainder. Okay, works for the remainder. What we need to change is those 3 numbers here. Is the coefficient. Because there's a coefficient of 2, I need to divide that by 2. Okay, divide the number by 2. What is the coefficient? You divide by the coefficient. If the coefficient is 3, you divide by 3 here. If the coefficient is 5, you divide by 5. If the coefficient is half, you divide by a half here. To adjust the number, adjust the coefficient. So what you have is 3 over 2, a quarter, and minus 5 over 8. And that gives you the same result. So what you will write is 2x plus 1 times 3 over 2x squared plus a quarter x minus 5 over 8 plus minus 11 over 8. And that gives you the px. And that is the same result as the long division gives you. It's faster than long division. Yeah, this is faster than long division. But the thing is, like, if you can't remember to divide the 2, the result will be different. But like, if you can remember that, so definitely you can use this method here. But it only works for divide by linear. If it's quadratic, you must use long division. Everyone get this method? How this method works? How to fill in each box? This only works for linear, and we'll use that to factorize cubic later. Okay, we'll use this method, so you need to learn this method. I'm not going to go back to long division after this. Okay, so if you really like long division, you need to find your own way to do long division. Okay, so let's come back to the notes. So to evaluate p negative 2, we know that will be a 0. Okay, to evaluate p negative 2, that will be a 0 because that's the factor theorem. You have this x plus 2 as a factor, so p minus 2 will be 0 remainder, so it's equals to 0. Okay, I have finished this page. Let's go to the next page. I need to complete the next page. Okay, find the remainder. Find the remainder when you divide by x minus 2. So we know P2 will be the remainder, right? P2 will be the remainder. When you make x minus 2 become 0, then x equals to 2. You sub x equals to 2, which is P2 will be the remainder. So P2 equals to 8 minus 3 times 4 plus 2 times 2 plus 6. That is 8 minus 12 plus 4 plus 6. That equals to 6. But I want to show you the fantastic thing of this box. This can give me all the information I need. Remainder theorem can only tell me the remainder, but not what you have for the QX, not the top part. Like you don't know what is the integer part. So I can set up this box. Well, 1, negative 3, 2, and 6. What I will substitute is a 2 here. Quickly complete this one. Copy the number 1 there from the both. 1 times 2 is 2. 2 plus negative 3, you have negative 1. Negative 1 times 2, you have negative 2. Negative 2 plus 2, you have 0. 0 times 2 give you 0. 0 plus 6 is 6. You have the remainder. The remainder is just 6. Okay, the remainder is 6. But at the same time, you can also say px equals to x minus 2, x squared minus x, and then plus 6. X squared term, x term, constant term, and remainder. The constant is 0, so we have x squared minus x. It's still quick. Maybe it's even faster than evaluate P2. So if you really know what to do with the numbers, and it's all integer easy numbers, very quick to calculate. But you also need to know remainder theorem, okay? You also need to know remainder theorem. Yes? That times the always type with the number you have at the beginning and add the next row, next column. Okay, next one. Well, divide by x plus 1, so we will evaluate p negative 1. So it's negative 1 minus 4 minus 1 plus 6. You get a 0 here. Well, I can still go for that one. I want you to get used to this method because we'll use that. We keep using that later. 1, negative 4, 1, and 6 for each coefficient. Must write in order. Okay, must write in order. What I want to put in is negative 1. Always copy the top number, which is 1. 1 times by -1 is -1. -1 plus -4, which is -5. -5 times -1, you got 5. 5 plus 1, you got 6. 6 times -1, -6 plus 6, 0 here. So Px equals to x plus 1. Okay, it's x minus that number, so it's the quotient. So x plus 1 and x squared minus 5x plus 6. No remainder. We can see there's no remainder, and we can also work out what Px equals to as well. And I can further factorize that. That's x minus 2 and x minus 3. Any questions to this method, like this box? Any questions to that? Okay, if you don't have any questions, let's forget this for the next 10 minutes, because we will need to go back to quadratic. Quadratic is the basic. Okay, if we want to factorize a cubic or a quartic or polynomial of power 5, we need to keep finding linear factors. I'll tell you how to find it. You keep finding linear factors until you reduce the thing into a quadratic. And we can factorize quadratic easily if it can be factorized. So, for example, I find the linear factor, give us the linear factor x plus 1. Then we have a quadratic, which I can factorize easily here. So we need to reduce a higher power until you reach a quadratic, and then we factorize the quadratic. So what's the method for factorize quadratic, and can we always factorize a quadratic? Well, the answer is no. You know, like some quadratic cannot be factorized. How we test it is we check the discriminant. If the discriminant is less than 0, then we make the decision this quadratic cannot be factorized. So don't try all the method and then find, oh, I can't factorize it. Try that earlier, okay? Try the discriminant earlier. Then say, oh, I can factorize or I can't factorize. Okay, make the decision first and then try the method. So how many methods we have? Like, we basically follow 3 methods to factorize quadratic. The first method we will use is when you're missing the middle x term, which is x squared minus a constant. So in this case, we can use the a squared minus b squared formula to factorize that. So what I can see here is I can make it into root 2x and then squared minus a 4 squared. And then there's a root 2x plus 4 and root 2x minus 4. Yes? Yes, definitely you can. And then you're left with the 8. And then the 8 needs to become 2 root 2. So it's the same thing. So I just think it's easy to change the first one. You can change and you can take 2 as common factor, definitely yes. For the second one, well, a 3 is a common factor, so I will take out the 3 first instead of put 3 as a root 3, because I can't see a square number here. I can't see a square number here. That's why I'll take the 3 as common factor. So that's x minus y squared minus 25y squared. Then the 25y become 5y squared. That's a square number, easily. 5y squared is 25y squared. And then what I will have is 3. X minus y is the a plus b. X minus y minus b. Okay, use the difference of perfect square formula inside. And then simplify x plus 4y. X x minus 6y. Okay, the next thing is when you have three terms, like x squared, x, and constant term, if the number are nice, like the number are good, we can use the cross multiplication method, or I think you have the grouping method, like some of you using that one, to factorize that. For example, the first one here, we can see at 8 can become 2 and 4. It's possible to make the middle number -2 here. So we want to create -2 by using the coefficient of the x squared term and the constant term. So what I'll do, the x squared, we will have 1 and 1. So what can make 1? 1 and 1. And the -8, well, 2 and 4 can make 8. I need a -2. I want to make a -2. So I'll put the negative on -4. Cross multiply them, -4 plus 2 give you -2, which is the middle number. So I will have x minus 4 and x plus 2. That should be what you have learned last year. Okay, so factorize quadratic. Okay, if you read vertically, the 1 and 1 will make the coefficient of x squared. If you times -4 and 2, that will give you -8. And then you cross multiply them and add them, you should achieve the middle number. So that's how this method works. When the coefficient is 1, maybe you can see it already, so you can maybe directly write out the answer. But it's a bit hard to write this one. Okay, it's a bit hard to write this one. For this one, I would like to take the negative out first. Because I want to see a positive x squared. So I will try to factorize the thing in the middle. Okay, I'm trying to factorize the thing here, this one. So a 15, what can make a 15? So 3 and 5 can give you a 15, or 1 and 15 will give you a 15. I will start with, this is a trial and error process. I will start with the number which close to each other, which is the 3 and 5. Normally is the number close to each other. And I have a -12. What -12 could be? 2 and 6, 3 and 4, 1 and 12. Well, because I have experience, I know this one should be 3 and 4. Because I want to make it 11. Want to make a 20 and a 9. Will give you 11. But I need a -11, so I need a -20. So the negative will be on 4, not 3. What we can see is a -20 plus a 9. That's -11. So that's a minus 3x minus 4 and 5x plus 3. That's the coefficient of x, that's the constant. So read in horizontal, okay, horizontally. 3x minus 4 and 5x plus 3. This is because the number are good. I can just use this method to do it. Sometimes it's not possible to do by this method. It's not all the quadratic can be factorized by this method, okay? All right. That's another like easy method. If you can just use cross multiplication, that would be great. But in some case, we can't. For example, this one. Well, a 1 can't make 8. Doesn't matter how you factorize it. So also I will test the discriminant. Discriminant is 64 minus 4, which I can definitely factorize it. The last choice we will use is completing square. Okay, the last thing we'll use is completing square when we have no choice. We know it can be factorized, but I can't use cross multiplication. I can't use the a squared minus b squared. So I'll use complete square. So to complete square, we have x squared minus 8x, L plus a 4 squared, L minus a 4 squared, and then plus the 1. So it's x minus 4 squared minus 15. So 15 can become a root 15 squared because that's a number. What's the question? To make sure it's above 0, and then I know it can be factorized. Above or equals to 0. I know it can be factorized. If it's less than 0, it's not worth me to even keep going with it. Yeah, that like it can't be factorized. We leave it. Yeah. Okay, that's how we factorize this one. Okay, for the next one, in order to factorize this one, I need to think about the discriminant. My discriminant will be 4k squared minus 4. Well, that's something I'm like not sure. Okay, that not sure. I need that to be greater or equals to 0 in order to factorize it. I need that to be greater or equals to 0 in order to factorize it. So I need k squared minus 1 to be greater or equals to 0. K plus 1 and k minus 1 needs to be greater or equals to 0. So what I will have is this graph here. Minus 1 and 1. Greater than 0, I need k belongs to negative infinity to negative 1 inclusive, union 1 to infinity inclusive. So I need greater than 0, which is this part and this part. The x will be here and here. Well, a little bit revision on quadratic inequality. So if k belongs to those values, I can factorize it. Okay, I can factorize it. I may run a little bit late. Just wait me 1 minute to finish up that. So I can complete square for this one. We have x squared minus 2kx, L plus k squared, and L minus k squared, and then plus 1. So what I have here is x minus k squared, x minus k squared. But be careful with here. I need a minus bracket k squared minus 1. I need a minus bracket. I need a minus. Okay, I need this minus because I want to use a squared minus b squared formula. So I need the minus here. I can't put the 1 in the front. I can't make the plus. I need the sign minus. So that equals to x minus k squared minus square root k squared minus 1 and then squared. In order to factorize, I want to use the a squared minus b squared form. Therefore, I have x minus k plus square root k squared minus 1 and x minus k squared minus 1. But the thing I need is k squared minus 1 is greater or equals to 0. That's what I need. K squared minus 1 is greater or equals to 0. What can satisfy that is this domain can satisfy that. Otherwise, I can't factorize. Okay, otherwise I can't factorize. If k is in between negative 1 to 1, I can't factorize it. Okay, so that's the revision on how to factorize a quadratic. That's the first check, and then we have 3 methods to factorize it. Homework is I want you to try example 6 because it's a really long question. I don't want to spend too much time on class to give you time to do it. So try this one tonight. It's a quite long question.